Okay, let's unpack this. If you're managing any kind of organization, a factory, a design studio, whatever it is, you live or die by your budget.
Hmm.
But trying to predict your costs, especially when your activity level is all over the place, that's where the whole financial plan can just, fall apart.
It really is the universal truth of cost accounting, isn't it? We wish everything was simple.
Right.
Purely fixed, like a CEO's salary, or purely variable, like the plastic for one single widget.
Mm.
But the reality is that most costs are, well, they're mixed.
Mixed. They have a bit of both. It's like a hybrid car. It runs on two different power sources.
That's a great analogy.
A utility bill is a perfect example, right? You
Yeah.
have that fixed base charge just to be connected, even if you use zero electricity. That's your floor.
Exactly, your floor cost. And then every kilowatt hour you used, every machine that runs that adds a little bit more on top, that's your variable piece. And if you can't accurately separate those two,
You're essentially flying blind.
yeah,
You can't set prices properly. You can't forecast for the next quarter.
you're just guessing.
And that separation is our mission for this deep dive. We're getting into two very specific techniques that are essential for any manager trying to get a handle on these mixed costs. The scattergraph method and the high-low method.
One visual, one more mathematical.
Let's start with the visualizer then,
Yeah.
the scattergraph. I know this is often the first step people recommend.
It should be. It gives you context before you just start plugging numbers into a formula.
I appreciate that visual first approach. So you're basically taking historical data, say the last year of activity and costs, and you just plot it on a graph.
Yep. Activity. So machine hours, units produced, that goes on the horizontal axis.
And the total cost goes on the vertical.
Right.
So what's the immediate number one goal of doing this?
The primary goal is really twofold. First, you just want to see the overall pattern. Do the costs actually follow something that looks like a straight line?
And second,
Second, and this is critical, it helps you spot any wild data points outliers.
okay.
If you had a month where a key machine broke down or there was some other disaster, that point is going to be way off the chart. And you'll know to ignore it when you do your calculations.
That's a really valuable insight that pure math alone would just miss. It would just average it in.
It would. It would skew everything.
So once we plot the points and we see, okay, they generally follow a line, we then draw a line of best fit through them. What does that line tell us immediately about the fixed cost?
The fixed cost is defined by where that line of best fit hits the vertical axis,
Y-intercept.
the y-intercept.
Right.
That point is your calculated minimum cost. It's the cost you'd have if your activity level was absolute zero. It's the rent, the basic overhead.
So if the fixed cost is the y-intercept, then the variable cost has to be the angle of that line.
Precisely. The slope. The variable cost per unit is represented by the slope. A shallow line means your variable costs are low.
And a steep line means they climb really fast with production. Okay, so we've found the conceptual heart of this whole thing. The slope of the line, in any kind of cost analysis, is the variable cost per unit. It's the definition of how much cost changes for every single unit of change in activity.
And that visual idea is, of course, rooted in a mathematical formula we all learned a long time ago.
Oh, don't tell me we're going back to high school algebra.
We are, but this time it actually helps the bottom line. It's rise over run.
Rise over run, I do remember that.
The variable cost rate is always calculated with that ratio. It's the change in cost, which is the rise, divided by the change in activity, the run.
So if my costs go up by $5,000 when I make another 1,000 units,
Then your variable cost is 5,000 divided by 1,000, $5 per unit. That formula is the master key for all of this, whether you're using a graph or the shortcut we're about to talk about.
that makes perfect sense.
Yeah.
But the scatter graph, drawing a line by hand seems a little subjective. My best fit might be different than yours.
It can be, absolutely. It's an estimation.
So if the scatter graph is the visual estimation, then the high-low method is the mathematical shortcut that promises a bit more precision.
Right, let's move to that shortcut. It's very common because it is incredibly fast. And what's fascinating here is how it simplifies things. It just focuses on two data points. The period with the absolute highest activity and the one with the absolute lowest.
That throws everything else out.
Throws it all out the window.
See, right there is my natural skepticism. Why would you trust only 2 points?
Yeah.
Like you just said, what if one of those extremes is actually an outlier?
That is a fundamentally sound question.
Yeah.
And it's why the high-low method is not the most accurate method available.
Okay.
That honor would go to something like regression analysis, which is a bit more involved. But high-low is a fantastic Approximation, when speed is what you need, it gives you a quick, defensible estimate for an internal report.
So it's a quick and dirty method, but a useful one.
Exactly. It sets the boundaries. It assumes the cost behavior between those two extreme points holds true for everything in between.
Got it. Okay, that clarifies its use case. So let's walk through the specific calculation with the data we have.
All right, so we're looking at manufacturing costs and the activities of direct labor hours. We have identified our two key data points.
The high point was November. That was their peak month. They hit 18,000 direct labor hours, and the total cost that month was $90,000.
And the low point, that was September. They only logged 4,000 direct labor hours, which resulted in a total cost of $48,000.
Okay, so now we apply that rise over run formula. Change in cost divided by change in activity. Let's start with the numerator, the rise.
So we take the high cost, $90,000, and subtract the low cost, $48,000.
Okay, 90,000 minus 48,000. That gives us a change in cost of $42,000.
Right, so that 42 grand is the extra cost they incurred just by going from their lowest activity level to their highest.
And now for the denominator, the run. That's the change in activity. So high activity of 18,000 hours minus the low of 4,000 hours.
Which gives us a change in activity of 14,000 hours.
So we've now isolated it. The total cost increase was $42,000, and that was caused by a total activity increase of 14,000 hours.
The final step is just to divide them. Find that rate.
We take the $42,000, divide it by 14,000 hours, and the calculation gives us a nice clean number.
It does.
$3 per direct labor hour.
And that's your variable rate, based solely on the high and low points. If you're in a planning meeting, you now have a solid defensible number for how much cost you add for every single hour of work.
That structured approach gives you an answer so quickly. But we're not done, are we? The goal was to separate the mixed cost. We've only found the variable part. We still need the fixed part.
Yes. This leads us right into the synthesis. Both methods, the scattergraph and high-low, are designed to give you that $3 figure. But once you have that variable rate, finding the fixed cost is just simple algebra.
Right.
I mean, if we connect this to the bigger picture, you know the total cost formula is just your total variable cost plus your total fixed cost.
So we're solving for the fixed cost. We can just take the total cost at any point, subtract the variable part we just figured out, and what's left over must be fixed.
Exactly. Let's prove it with the high point data.
Okay, the high point was November, 18,000 hours, and a $90,000 total cost.
Step 1. Calculate the total variable cost for November. So we take our new rate, $3 an hour, and multiply it by the 18,000 hours they worked.
$3 times 18,000 hours is $54,000.
Okay, so of the $90,000 total cost in November, we now know that $54,000 of it was variable.
Which means the rest, it has to be fixed.
It must be. So $90,000 total minus the $54,000 variable.
Leaves us with a fixed cost component of $36,000.
And that's your number. That's the fixed cost floor.
We should probably double check that with the low point data just to be sure it's consistent.
A good idea. You always should. So the low point was 4,000 hours and a total cost of $48,000.
Yeah, so first the variable part. 4,000 hours times our $3 rate here. That's $12,000 in variable costs.
And the total cost was $48,000.
So 48,000 minus that 12,000 variable portion, and we get $36,000 again.
It's stable. That fixed component holds true across that entire range of activity we observed.
So we did it. We've unmixed the cost. The full cost structure is total cost equals $3 times your labor hours plus a fixed $36,000.
Exactly.
Now, this isn't just a math exercise. This is managerial rocket fuel. Once you have that $36,000 fixed number, what can you actually do with it? Why should you, the listener, care about that number?
You should care because that number allows you to build a flexible budget. Instead of one flat prediction for the year, you can now predict your costs at 10,000 hours or 12,000 or 15. You suddenly see your true marginal cost, that $3, and you can understand your company's operational leverage.
And it must change how you think about pricing, right?
Yeah.
Knowing that your cost floor is $36,000 lets you set minimum prices to make sure you're always covering those commitments first.
Absolutely. It transforms guesswork into actual strategic financial modeling.
So to summarize the core takeaways here, what is the slope?
It's the variable cost per unit.
What's the fundamental formula for both of these methods?
Change in cost divided by change in activity.
And what's the ultimate goal of all this?
Separating those mixed costs to find the stable, fixed floor are $36,000, and the variable rate of change are $3 per hour, finding the moving and non-moving parts of your business.
So what does this all mean for you? It means you now have the tools to look at a complex cost and quickly isolate its components, either with a visual estimate or a fast mathematical shortcut.
Mhm.
You can see how the relationship between your highest and lowest cost points actually defines your variable rate of change.
It's an incredibly powerful forecasting tool, but we do have to circle back to that critical limitation you pointed out earlier.
The fact that we only used 2 data points.
Well, not just that. We calculated this $3 rate and the $36,000 fixed cost based on activity that was only between 4,000 and 18,000 hours. This is what accountants call the relevant range.
The range of activity where we actually trust this cost behavior.
Exactly. And this raises an important final question for you to think about. If this company suddenly scales up operations next month to, say, 30,000 hours way outside that relevant range, should we automatically trust that $3 variable cost?
Probably not.
And will that $36,000 in fixed costs actually stay fixed? Or might the company need to lease a whole new building or hire another supervisor, causing that fixed cost to suddenly jump to a much higher level? Cost analysis is never static, and understanding those limitations, that's the next level of expertise.